Hi, my name is Amelia,
My name is Fatima.
and the problem that our project aims to solve is deep blurring images from various blur types back to the original clear image. We decided to use deep learning, namely because, based on our research, it seemed that using this method was the most effective way to deblur images. For our models, we used a Kaggle dataset containing defocused images, motion blurred images, and the sharpened versions of those images. We additionally created three more datasets with various Gaussian blur intensities. We implemented our models in Colab and also set up our own server with multiple GPUs to run a Jupyter notebook in. This was very helpful for speeding up the time it took to run some of our models. The first network we implemented was SCRNN, which stands for Super Resolution Convolutional Neural Network. And this is a deep learning technique on which we performed a hyperparameter search to determine which parameters work best for which data sets. We focused on finding the best batch size, learning rate, activation function, and layer amount. To evaluate the effectiveness of our models, we use PSNR, which stands for peak signal to noise ratio, and LPIPS, which stands for learned perceptual image patch similarity. Using these metrics, we compared the sharpened original image to the resulting deep blurred image from the last epoch of each model for similarities.
First, we ran our SRCNN models on defocused, motion, and Gaussian blurred images with varied hyperparameters to see which performed best. After running our first phase, we found that models with Gaussian blurred images yielded much better results than defocused or motion blurred images. For our next phase, we decided to further experiment with hyperparameters, but with various Gaussian blur intensities this time. We ran our models on images with Gaussian sigma levels of 5, 10, and 25, and we found that 5 performed the best, then 10, then 25, which is probably because 5 was the least blurred of the three. For our hyperparameter results, we found that the best parameters were larger learning rate, smaller batch sizes, tan-H activation functions, and models with 3 layers. At the same time, we wanted to know whether our results from phase 1 were maybe just due to SRCNN being a poor algorithm for deblurring images. So to further experiment with Gaussian blurred images, we implemented a UNet algorithm to see if it could produce better results than SRCNN. Throughout the experiments, we found that models with learning rates around 1e-5 seemed to perform better. So keeping this in mind, along with the average training time of a UNet model, which is around 3 hours, we produced 4 UNet models that we believe best represent the capacity of the algorithm. After running the models, we found that UNet performs the same, if not worse, than SRCNN for deblurring images. In general, we learned that every model and architecture has multiple factors influencing its performance, and that many experiments and trials are required to narrow down the optimal way to deblur images.